Okay, hi everyone. Welcome to the Fusion 360 simulation extension. My name is Ajay, and I will be taking you through some of the aspects of the simulation extension. I am the technical specialist at Baynes for the manufacturing process plant environment. Let's get cracking. So on our agenda today, we will be discussing a quick introduction of what Baynes is, who we are, what we do. Then we will have a quick overview of Fusion 360 in its core form, and then we will then move on to the extensions and specifically the simulation extension, which includes static stress thermal simulations, nonlinear static stresses, shape optimizers, and many, many more. We will also further discuss a little bit about how we can help you as Baynes, and then we will open the floor a little bit to our questions before we actually conduct our lucky draw. The lucky draw is for a year subscription to CAD Learning, which is a very handy e-learning portal, allowing you to learn 50 or more Autodesk products at your own pace, at your own time, and at your own convenience. Let's get moving. So Baynes, who are we? What do we do? Let's begin with who I am. My name is Ajay Gangadharan. I am a technical specialist in the manufacturing process plant environment at Baynes. As mentioned previously, I am a mechanical engineer with experience in design and manufacturing industries. I have been a project engineer and a project installations manager in the construction industry as well. My qualifications are: I have a mechanical engineering degree with a postgraduate qualification in engineering management with specific focus on quality management and lean manufacturing. My email address is on the bottom left corner. Then let's move on to who Baynes is, what we do, who we are. We provide solutions. We are essentially a solutions providing company who deals with who does consulting. We do education, and we deal with hardware and software provision to solve problems. Now, the consulting, I mean, we work with people, processes, business assessments, CAD consulting, whether it's BIM, data, or even simulation, as the topic is actually today. We educate as an accredited classroom and virtual training instructor with Autodesk, and we also provide customized user and project-based training, as well as a partnering up with the self-paced e-learning platform. The CAD Learning year subscription that you stand to win is actually part of that. We are an Autodesk Gold Partner, and we partnered up with both Leica as well as ClearEdge. In terms of that, recently we've also partnered up with a data management solutions provider in Orange, and as you can see, we are also partnered up with CAD Learning. We have a footprint in the manufacturing, building, energy, process plant, and civil industries. We have a YouTube channel, and considering that this is the second in our Fusion Extensions video series, as well as the third in our series of Fusion videos, the previous webinars that we have done have been recorded and placed on our YouTube channel. So please go have a look at that if you missed it in the previous previous sessions, or alternatively, if you would just like to do a recap, you're more than welcome to go and have a look at that. We also have a whole bunch of videos on YouTube with regards to the software and solutions that we provide, and a lot of other interesting things when it comes to the environment. So please have a look at that, and when you have some time, like, share, and subscribe. So yeah, let's do a quick overview on what Fusion 360 is. Right? Fusion 360 is not just CAD, it's not just CAM, it's not document management, it's not simulation, electronics. It's all of these, all rolled into a single entity, a single very flexible entity that actually allows you seamlessly to switch between different modes, that allows you to take in everything from product definition all the way down to the shop floor production, where it gives you a single solution for the entire product development and prototyping process all the way up to manufacturing. So as you can see here, we've got solutions for the product definition, the engineering, the production engineering, as well as the shop floor section, with the different profiles of person that will be using the different aspects of Fusion 360 in each stage. Fusion 360 takes it a little bit further in that it actually allows 50 or more native files to be brought in from different software packages to be worked on in Fusion, and all your design, simulation, and so on will then be able to be done via Fusion. Fusion 360 works on a very powerful AnyCAD engine that actually allows you to, like I said, integrate seamlessly with a lot of other software packages. And even easier, it actually allows real-time updates with other Autodesk software. If you see on the right-hand side, including but not limited to Autodesk Inventor, Moldflow, NetFab, FeatureCAM, and so on. Autodesk is actually very, very much on the interoperability aspect of things, and we will be able to do a lot more in this single, unified, very flexible piece of software that you'll be able to use to do all of this. Just imagine a single engineer in a small business that's actually going into the manufacturing aspect of things. That engineer would have to wear multiple hats or do multiple roles. And in the past, that would mean multiple pieces of software, potentially at an extremely large cost. This Fusion 360 flexes to your needs in the sense that it actually has a lot of parts that allow you to move to wear those multiple hats using a single package in a flexible way. And the extensions, all it does is actually adds to that level of functionality from a single user to an enterprise grade level. It allows you, so things like generative design actually give you thousands of solutions for a single problem that you may have, thousands of potential solutions that you can select as a user or as an enterprise to go through. So, I mean, just to give you an example, is this generative design concept will actually do the multiple iterations for you for multiple design types. Fusion takes it even further in that it actually connects you to your entire product ecosystem, namely from the start of the project initiation phase all the way down to manufacturing and even down to production. It allows you to collaborate seamlessly with team members wherever you're sitting, because it's a very much online and cloud-based system, and it allows you more time for innovation than for iteration. And by that, your things that you can do, you can spend more time designing your product than to actually manage your documents or whatever, because Fusion does all of this for you. It allows you to actually move your business forward with full agility and full flexibility, with in its core, along with all of its extensions, including the Fusion Manage extension that allows you to do data management as well, and partner model management and such things. So let's talk quickly about the Fusion 360 extensions that are available. Fusion 360 extensions are available in 3 different aspects of your product design and manufacturing cycle, or timeline, if you want to call it that. The Fusion environment actually allows you access or different things that you can do within the design, manufacturing, and the data or process management parts of your cycle. Today we'll be talking about the simulation extension, but within design you've got product design as well as generative design. In the manufacturing you've got the 4 that are actually shown there: additive build, additive simulation, nesting, fabrication, machining, and then you've got Fusion Manage that allows you to do your data management. Why use Fusion extensions? Why would we use them? I mean, as much as Fusion 360 in its core is actually a very all-round and flexible product, the extensions themselves allow you a lot bigger functionality. For example, your manufacturing extensions will give you a lot more options in terms of the types of manufacturing that you're able to do. So using that, you can eliminate your disconnected deployments, using specialized technologies, all on a single flexible platform. We can simplify your design and manufacturing using automated workflows, collaborate with your team members wherever they may sit in the globe, as long as they have an internet connection, and thus reducing your time to market. And as we know in this business, time is money. Fusion 360 allows you totally flexible access, allowing you to pick and choose what specific needs that you have and pay only for those using a 1 or a 3 subscription whether it's for the Fusion core or for the extensions that are available. So let's jump into simulations. Simulations, what do we mean by simulation? So simulation in a way it's part of digital prototyping. So we can use the tools in the simulation workspace to minimize your physical prototyping and destructive testing requirements, in that your time to prototyping for testing your parts, you can do all of that digitally and online, so that you can reduce the number of iterations that you have to do. And using the different material options that you've got, you can compare the effects of the different materials in different conditions, and using your geometry optimization function to actually do your testing and things on testing for manufacturing as well as for in real conditions, to see that you've actually managed to get the right part, so that you don't actually have to do the initial prototype and you don't have to work too many iterations to make sure that your product does what it needs to do. And you can gain, by doing so, you gain a valuable insight at an early stage, so that your costs can be reduced and your time will also be reduced quite significantly. Where you would have to do 5 or 6 physical prototype iterations, you would probably only have to do the one to do the final testing, since the power of the simulations is that it actually gives you the opportunity to check it before you manufacture it or make it in the first place. As a product development engineer, when we're in the product development lifecycle, there's a whole bunch of questions that we need to ask to make sure that our parts actually do what they need to do. In doing so, we need to evaluate the effects of structural and or thermal loads that are being placed on your part in reality. So these questions will be: is my design strong enough to withstand the expected loads or vibrations? Fair question. Can it withstand stresses induced by temperature gradients in addition to stresses associated with static or transient mechanical loads? Does it fail under a heavy load? Does it overheat? Is it prone to resonance? Is the operating temperature acceptable? Will long and slender structures fail due to geometric instability or buckling when subjected to compressive loading? So all of these are questions, among others. These are questions that we will, as designers and as people in the production environment, need to ask ourselves to make sure that the product that we're creating will work in the environment in which we are creating this for. That is what some of the questions, many of these questions can be answered simply by doing a digital simulation. What we also need to keep in mind is that finite element analysis is considered a method for digital prototyping, which I've spoken about in brief a little bit earlier on. But the digital prototyping methodology, and that actually allows the small enterprises to actually be on par almost with the larger enterprises, because the amount of resources required for prototyping is significantly diminished by being able to use simulations with our simulation extension. So let's talk a little bit about, and let's deep dive into our simulation extension that is for Fusion 360. So our simulation extension allows us a number of various environments or different types of simulations that we can do to use to be able to simulate, I guess, all of the different environments, many of the different environments in which our products will be working, and even some of our manufacturing environments where things like plastic injection molding will actually come into play. So we can actually check to see that we will be able to manufacture the product properly as well. So some of the aspects of the simulation extension are static stress simulations, electronics, cooling, which is actually a preview functionality. Now, the preview for which the previous video that we did on the product design extension, I did touch a little bit on how to activate your preview functionalities in Fusion. Along with that, we've got modal frequency simulations, thermal stresses, structural buckling, nonlinear static stresses, event simulations, shape optimization, and as mentioned, the injection molding simulation. What are the benefits? Some of the benefits of using the Fusion 360 simulation tool or simulation extension is that we have access full access to diverse types of simulations with what you need, and we have you can simulate what you need using the advanced finite element analysis tools that are available from a mature simulation software. Now, we take these simulations, which generally most people are afraid of because it's actually quite a complicated process. Fusion 360 actually makes it very, very simple for us to do. We can compare design changes and revisions without the need to export models and sort of jump between different specialized software tools. And we can ensure plastic part moldability by detecting and visualizing, as well as simulating the actual molding process, as well as how the parts would react under the molding process. Let's move on to static stresses. What is a static stress, guys, ladies and gentlemen? A static stress is a single point load, or not necessarily a single point load, but a single load that is not dynamic, it's not moving anywhere. Fusion 360 allows you to actually simulate how a static stress and how a part would behave under static stress conditions, where it simulates how the model responds to structural loads and constraints. It gives you the displacement, the stresses, the safety factors, the reactions, as well as the common criteria when you common failure criteria rather, when you actually run such a simulation. As you can see on the right-hand side, the graphic is actually showing a little idea on how static stress simulation, along with its constraints, is actually performed. Now, the assumption here is that it is a small displacement and the response to the static stress is linear. So we quickly move on to the next attempt, the next thing that we need to actually speak about, which is the modal frequencies. Now, modal frequencies is a cyclic stress loading, and certain parts will react very differently to the types of cyclic loading that they may be expected to bear. And this actually gives you that opportunity. So your resonant frequencies also form part of this modal frequency thing, where you've got certain parts that actually vibrate under certain frequency of loading, and that resonance is also actually covered in this particular simulation methodology. What it does, you can simulate the natural free vibration characteristics of a part or assembly, and this accounts for the effect of structural loads on natural frequencies and, as I said before, resonance. Now, the results that you get out of this are that the shapes of the different vibration modes, their corresponding frequencies, as well as the mass participation factors. What do we mean by mass participation factor? The mass participation factor is how the part would react depending on how the mass is distributed. So your resonant frequency will change, the way it reacts to different loading will change depending on where your masses are found. So in the example that you see in the graphic, the edges are the ones that flex the most. Now, what you can do is you can probably add a little bit of material to the edge if you wanted to allow it to flex less. However, that may cause another problem in that you're causing additional strain on the center point of this plane. So that's just an example of how this would actually work. So moving on quickly, we have the electronics cooling, which is in preview, like I said earlier. And so what this is basically, you've got PCBs, printed circuit boards that actually heat up under operation. So certain temperature fluctuations may change the way in which the printed circuit board works and how the effectivity thereof and the efficiency. So here we can simulate the environment that putting loads as well as heat stresses on the PCB. It shows you how the heat would actually behave and how putting in a heat sink or a change in how you would be able to remove heat from that center point. The outcome will show you the temperature of the components, surrounding air, and the effect of heat sinks and fans. So if you had actually put a fan on your chip, how would it actually dissipate the heat for you? You could add a critical temperature to your PCB components and actually just determine how it would fail under those circumstances, if it would fail under those circumstances, and you can also create a safety factor in doing so. Yeah, so then moving on, we've got a thermal simulation environment as part of this as well, which we can actually move on and discuss very briefly. So the steady state thermal simulations that are included with this extension offer designers and engineers the ability to test the thermal management of the designs. The simulation type examines the potential of a design to absorb, deflect, or shed thermal energy through conduction, convection, and radiation, allowing designers to ensure that hot things stay hot and cool things remain cool. While more sophisticated tools are available for electronic, specifically this tool is a great first step at identifying sink effectiveness and overall thermal energy dissipation through a design. Simulation extension uses limited cloud solves of the study type with no per cost study involved. All this and more in the Fusion 360 simulation extension. So briefly, this is what thermal simulation is. Let us then move on to thermal stress simulations. So thermal stress is a simulation model where you're looking at non-uniform distribution of heat. So where the heat is actually sitting in localized spots or in a distributed load. So what this allows you to do is to actually in combination check thermal stress distribution, how the part will react to the stress due to the temperature update or energy move through the part, and it also combines that with the structural load stresses and temperature induced stresses, allowing you to just determine how the part would react under those conditions. So moving on to the next simulation model that we have available in our simulation extension, we're speaking about something called structural buckling. Structural buckling is actually the mechanism by which a structural part will actually fall, will buckle or bend under a certain load, whether it's static or dynamic. This is recommended to be used in conjunction with your static stress simulation, and so that you can actually then work out your safety factors and so forth using you use the two in conjunction so that you can actually check the safety factors, how the product actually behaves under certain conditions. And this is now for the tools where structural parts which have the slender type commands, as you can see the little table that's actually bending or buckling as the load is being applied to it. Then, so what you're looking at here is that it simulates the effects of a compressive load on a structural component, whether it's a truss, a bridge, or any other building structure, or even if it's like a structure that's just putting something together just to add strength to it. You want to look at these trusses work under compressive loads, as you know. And so in conjunction with your static stress analysis, you will actually then be able to work out whether you can actually, whether the load that you're applying it's possible for the product to actually handle the load, or if it's going to buckle or bend under those circumstances. Now, if you look at this, you'll see that it gives you a multiplier. Now, the multiplier under 1, all that it shows you is that by the time you get to your specified load, this item is going to buckle. Now, you can almost equate that to something like a safety factor on the part. Obviously, you won't really necessarily go to a point where the safety factor is like in the mining environment 10 or 11, because that's then just over designing the part, like we spoke about a little bit earlier. So this is actually quite a handy one. Moving on to the next simulation mechanism that we've got what we call a non-linear static stresses. Now, the shape of your part and the way in which it deflects during its motion due to the force or the load that's being placed on it is simulated here, where it's in a non-linear fashion, because linearity is tiny minor deflections and it works on a single line. Now, you'll see that in the non-linear static stress, it simulates larger deformations. It simulates changes in contact from the load and the part, and its constraints to other parts when you've got larger loads being applied. The way in which this actually works is that when you apply a load, your part deforms, and when the deformation happens, the load and the stresses as a result of the load is changed due to the way the contacts are changing, due to the way the boundaries are changing, and how all of that actually interacts with each other. That's what this simulation is actually taking into account and showing you. This is a really realistic way of actually doing a simulation. And then the shape itself of the part that you modified, if you've got additional stresses in specific kinks or bends or curves, may also change the way the stress is distributed among your parts. So that also is taken into account when you're talking about nonlinear static stress. It allows you to actually look at your material behavior as well as give you multiple calculation increment options. The next thing that simulation that we're talking about is event simulation. So that actually shows you the different types of events, things that can happen, projectiles, and all of those things, which we will discuss next. Event simulation, which is included as a part of the extension offering, provides an even greater ability of capabilities over nonlinear stress by including the dimension of time. These simulation types can accurately examine transient responses to collisions, accelerations, and other nonlinear time-dependent loads. This means predicting behavior from drop tests, ballistic impacts, or even compliant and flexible structures like living hinges and snap closures. Fusion 360's fully automated contact solver tracks and calculates part interactions, including self-collisions. These complex studies are renowned for being resource intensive, but with these multi-threaded cloud. The results are calculated and returned in very short order over the cloud. Simulation extension users gain value with unlimited access to these cloud sources with no person cost involved. Whether you're a seasoned CAE analyst or just starting out, Fusion 360's event simulation tool is a powerful yet easy to use study guide. And then we're slowly going to move on to the shape optimization section of our Fusion 360 simulation extensions portfolio. The shape optimizer, what it does is it actually gives you the possibility or the opportunity to look at the different parts that you actually model, design, develop, and gives you the opportunity to actually remove material where needed or if needed. So in the situation where weight saving is important or material saving is important, and in some cases, even if you're 3D printing the part, it costs more to build a part than to cut it up. You will actually be able to save a lot of material when you simulate it in this manner. What it does is it actually takes the loads and constraints that you plan to put on it, or what in reality what it's going to go through, and gives you the opportunity to remove material from the part. So this concept is also known as topology optimization, optimizing the use of your material to achieve lightweight design goals. Yeah, so I mean, where weight saving is very, very important, this is a very, very handy tool that you can use. Then we move on to the injection molding simulation, which, as the name implies, it is a simulation on the injection molding process and how you would determine and create plastic parts in accordance with the injection molding ability that we have. It gives you the opportunity to check to see if there will be any air bubbles when you're doing the molding. So then it would give you suggestions on what you can do to improve and adjust your mold itself to allow the molding process to be performed efficiently and much better. It also gives you the simulation on how the plastic parts may deform in the molding process, giving you the knowledge to be able to modify accordingly. From these results, you can investigate the fill, visual defects, and warpage of your parts, and yeah, as a result, you'll actually then be able to make a very informed decision on how to set up your plastic parts to specifically align towards the manufacturing process. There we actually end our Fusion 360 simulations extensions. What we have done now is we've been through it is quite a lot of information to take in. Yes, agreed. So in our Fusion 360, we've been through static stress analysis simulations, modal frequencies. We've spoken about electronics and electronic cooling, thermal stress and thermal stress simulations, structural buckling, nonlinear statics, as well as dynamic event simulations, and the shape optimization, injection molding simulation as well. I hope that you actually, learned something from this, and that you're actually able to take this forward, and we will be able to assist you going forward. So how can we assist you as a company, as an entity? We actually solve our customers' problems through digital transformation, helping you to design and make a better world. in conjunction, in collaboration. What we do in order to actually achieve this is we have a consulting methodology, which we call high-adopt. So in this particular instance, we're talking about simulation, so we can educate you with regards to simulation extension. We can consult with you and assist you with that. We can assess your needs and then put your people, processes, and technology together with the purpose of actually using simulations to make a better world and to make the process, in your process, more efficient, and that being the outcome. So that's effectively what it is that from Baker Baynes that we can offer you. That's the ending our little presentation. Okay, so ladies and gentlemen, one of the questions that has come up is the sorry, 1 second. One of the questions that has actually come up is, what does it mean when you say cloud only? So we're talking about using the cloud and cloud tokens that are available on with Autodesk, that we can actually solve these simulations. It works with both simulations and with other Autodesk products, where you can actually use the cloud to do your rendering or your simulation. But using that, you need to actually purchase credits on the cloud. There are certain aspects, like you saw on the slide, some of them are cloud only and some of them are cloud or local. So the ones that are cloud and local, you're able to actually run the simulation locally on your machine. The ones that say cloud only, you're only able to run those simulations on the cloud. Now, what the cloud actually allows you to do is to limit the amount of resources that you will actually be required to use on your machine. So you can use a less powerful machine to run the simulation. So because the entire thing is done on the cloud. And in how you would actually do that is to purchase cloud credits, cloud credits or tokens that you can actually purchase from us at Baker Baynes. And those each one of them has a certain cost when it comes to those cloud credits. That is what we mean by cloud and where we speak about the simulation. And I mean, I think even when it comes to renderings as well, you've got the option to render into the cloud so that you can actually continue working on your PC while it's doing that. Do we have any further questions anything else? Anyone?
I see one here, just hold on. How secure is cloud based on the security of your business property design? So there is a Autodesk Cloud Security white paper. I am not the IT expert, but I know it's hosted on Amazon Web Services, and it has a whole bunch of tick boxes and things that it comply with. So what we'll do is we'll send you through that Cloud Security white paper afterwards, and we can discuss it in a little bit more detail. But I do understand that it is something that one needs to consider. Thanks for the question. Okay, that seems like all the questions for now, AJ.
Okay. In the absence of any further questions, let me then move on. Let us actually where you can find us. We have two offices. One is based in Cape Town at that address that's shown there, and then at the lower address is our Johannesburg office. We also do have quite a strong online presence, or via our website and the various social media platforms that are available. So thank you very much for attending, much appreciated, and I hope you learned something and that you can actually take something away from this webinar. Have a lovely day further.